Hello everybody and welcome back to Kerbal Space Program, where we are sending this second attempt to Gilly. I deorbited the first attempt after thinking there wasn't a thermometer, but there totally was a thermometer, and it was a complete waste of time and pointless. And it was wonderful. I will die on this hill. No, I will not. It was not wonderful. It was really weird. So, first things first, we need to set Eve as our target. So, of course, that means that we need to escape Kerbin. And the way that we're going to do that is that we are just going to simply do our standard slingshot around the moon. And so we will burn sometime around here-ish would probably be fine. A little later. That'll do. And then we don't need quite that much fuel burned. We can do simply something like this. And a little bit more retrograde to do something like that. That is a second moon encounter. So technically, we need to change this trajectory ever so slightly. That would be an escape there, but that would also be an impact, which is not helpful. Maybe we can just tweak this with a little bit of radial here. Like that. Not quite that much radial, I guess. That's only 1.6k. I definitely want to be at least 10 kilometers up. 140 is more than I was looking for. Just looking for that apoapsis to escape. There we go. It's a very, very tight slingshot there, but that'll do. So that's 837 meters per second. That is not bad. We will just barely rotate at all. I guess it's because the weight of this stage. I was expecting it to rotate a little faster than this. But okay, we're on 4x time acceleration, by the way. That's kind of extreme. But we do have a lot of weight still in our primary stage here, so it's not a huge surprise. I mean, we've got 1400 meters per second here. So we're going to be able to do our sun maneuvers with this. Or some of our sun maneuvers. Maybe not all of them, but a substantial amount of them, to be sure. So we are about in position now. And we want to burn this at T-minus 26 seconds. So as soon as we're just a little closer to position, there we go. We'll now warp us ahead towards T-minus 26. And we're almost there. Okay, we're gonna burn right now. And off we go. We are, of course, going to have to make sure that we hit this quite accurately. Also, the engines were a bit loud, so... Oh, that resets it. Exciting. Okay, well, we'll just sit about here for now. We've got about 15 seconds left in this burn. Just trying to... There we go. Okay, let's check our periapsis. It's fine as long as it doesn't keep going down like that. Why is it going down? I'm not currently throttled up. We're not in atmosphere. Why is this moving? If we go into time warp, it stops. If we come out of time warp... Okay, it seems to have stopped. Well, let's go ahead and warp to right about here. What just happened? I hit the wrong button, and I canceled the auto warp. We're now out here, where it is our current orbit. No, seriously, what is our current orbit? Did we escape? I'm slightly confused. Is this us? Yes, this is our orbit. Okay, how did that change so dramatically? This is nowhere near what our actual orbit was. I didn't mean to warp that far, I hit the wrong button, but I guess we'll just push out over this way. Or we could do it at the apoapsis, I suppose. It'd be less efficient. But do we care? I mean, we have a lot of DV on hand. I just don't understand how a time warp could have possibly changed our orbit this our trajectory this dramatically. That doesn't really make a lot of sense. Because I accidentally warped us too fast, right? But and too far. But that doesn't really change our trajectory, or at least it shouldn't. At any rate, we'll just burn the extra 191 DV and call it a day, and we'll burn this at the apoapsis, which means that we may actually be able to get away with burning a little less DV here. Yeah, a little bit less. Not sure how worthwhile that actually is. And I don't know what was causing our apoapsis over the moon to fall like that. It's a little strange, to be sure. Well, at any rate, we are just going to get to this maneuver node and just get out of here. Luckily, this thing is massively overbuilt, and we're not concerned. So let's just warp to this next maneuver, and cancel the warp because I keep pressing the wrong button. At least it's better to cancel the warp than it is to warp too far. So this is a 9-second burn. We want to burn this at T minus 4.5 seconds. So we will warp towards that. And here in just a moment, and off we go. That should be plenty. Yes, indeed. Okay. That is not plenty. We're going to stop this tumble. We're going to head back towards the prograde marker. Because after I closed that, it altered our trajectory. I don't know what's happening here. Maybe I was just looking at the maneuver node for that one. I don't know. Maybe I'm just completely out of my mind today. We'll see. But we'll just do that. And we'll freeze those physics. There we go. We did successfully escape, so next we want to set Eve as our target. 2.1 degrees. That's a fair amount, actually. We'll add a maneuver over here. We're going to need to change our inclination. About like that. And then we'll see after that what our intercept is looking like. That's 118 days out, though, so let's head to the Space Center and see if we have anything intervening between now and then. I'm not sure if we do or not. Let's see. The auxiliary module is in 213 days. Science rover Mark Duna is in 305 days. Okay, so we don't. Well, let's go. So at this point, we may as well just warp to this next maneuver. And we'll get oriented for that as well. In fact, I'm going to cancel this auto warp. And let ourselves get oriented. This is under 4x physics warp, by the way. Our reaction wheel is pretty small on this thing, but once we're done with this stage, which we will be pretty soon, but after the inclination change, we'll turn much faster. It's just a lot of momentum to change. I'm actually surprised that we're not going to be burning out this stage in our inclination change. But okay, I guess we'll take it. Okay, that is close enough. And we will warp to our next maneuver now. Excellent. So we're going to want to burn this, of course, at T minus 8 seconds. Realistically, we should probably just be locked to normal and not utilize the maneuver node. Okay, so we will be arriving here quite shortly. Let's be zoomed in on this so that we can see what's going on. This is still about an hour away. We're definitely going to want to warp in a little bit closer here. And maybe a little closer yet. Of course, we've got the floating point issue here. When we've got orbits this big, that is to be expected. Line renderers in Unity, after all, are not necessarily the most performant things if we have too many segments. Okay, so we're probably going to want to warp even closer. This is still another 11 minutes. Okay, how far out is this descending node? Still about 5 minutes out. We'll warp to about here and see how that's looking. Okay, it's definitely pushing out away from us a little bit. We'll warp in about another minute and then get in a few more degree change. It's definitely still moving away from us. So we're going to warp in another 27 seconds. Still moving away. We'll warp in another 23 seconds. There we go. That'll do. Excellent. Now, as far as plotting our interception with Eve goes, Eve is currently located awkwardly, so this may require an orbit before we get there, but we'll see how close we are. This is not going to be, I think, amazingly close. Actually, I'm completely wrong. That is amazingly close. We literally have an encounter first attempt. Okay. I guess I'm just completely discombobulated today. Well, we are of course targeting Gilly here, so we should probably not come in quite this close. And this would probably be completely fine. So that's just in another 26 days, and we know that we've got enough time to get that done. Of course, we're going to be burning out this stage quite quickly, which is good for our reaction wheels. So we'll just get oriented over here. We've got 47 meters per second left in our first stage, which is completely fine. And let's just get positioned over here. Reminder, This is on 4x physics warp. In future, we may want to have an extra reaction wheel, like right here. Might not be a terrible idea. Okay, we're pretty much oriented now. So let's go ahead and warp to next maneuver. That is only about 26 days away. Excellent. About 800 meters per second to get us there. It's almost like this design is overkill for going to Gilly or something, but we're planning on using this same design to go to other locations for communications infrastructure. So it's completely fine on that front. This is just kind of a test flight, and now we know that we should really probably have an SAS module somewhere in this stage. Or perhaps right here. Here would work too. Well, we just need a little bit more warp here. We're 4 days out. This is not warping the fastest I've ever seen. We're not all that far from Kerbal, really. But here we are. This is a 1 minute 5 second burn. So, of course, we want to burn this at T minus 32.5 seconds. My mind went blank for a second there. This is not going well. I had a hard time waking up this morning, and it's kind of showing. Just did not want to get up. Okay, so 32.5 seconds. So right now. And off we go. Our attitude control should be much better now that we've ditched a huge amount of weight. And our orbit is getting smaller. Fantastic. That is, of course, exactly what we want. Okay, so here we are. 300 more meters per second to go. And it's going to be a while before we actually have this intercept, of course. I don't think we're going to get the intercept before we have to do some of our other long-term missions. So that's completely fine. Okay, 10 more seconds left in this burn. We'll just come in a little bit more cautiously here. Okay. That'll do. Excellent. So our next maneuver will be encapsulation of the orbit here, although I kind of want to delay this to about here to encapsulate this orbit slightly better. We could even offset it this way and bring it in about like this, and then we just have to change our inclination, which maybe we could do at the same time. We'd want to go this way. I mean, that's not amazingly ideal, but it would in theory get the job done. This, however, is inauspicious. We need to go something like that. And maybe a little bit more prograde. What would that look like inclination-wise? Very close, actually. So it would look something like that. And then we can do our Gilly intercept. I don't know where Gilly will be by the time we get there. That's in 191 days. But we can cross that bridge when we get there. That is, I think, close enough. So let's head on back to the Space Center and see what we can do. So, in the tracking station, let's take a look at our long-term missions. 160 days on the Science Rover Mark Duna. 68 days on the auxiliary module. So this is our next maneuver here. Okay. And in fact, we're going to be doing all of our maneuvers before we get to our next destination. We should definitely be locked to the maneuver node, but apparently Valentina isn't skilled enough to do that. That's interesting. So I'll have to manually do it. Well, let's get ourselves positioned over here. There we go. Fantastic. And now, we can pretty much just warp to this maneuver. And what is this maneuver, in fact, attempting to do? Ah. That gives us a pretty close encounter. Can we fine-tune this at all? Yes, we absolutely can. And so we shall. 4, 3, 2, 1,000 kilometers. 174 kilometers. Okay, that looks like it's about the closest we can get going that way. And that way. We may have to do a little bit of inclination changing if we want to get closer. Yes, indeed. That's under 100 kilometers. Overshot a bit there. It's 11 kilometers, 9, 7, 6. Okay. With that inclination change, can we get any closer? No. Okay. At this distance, even single mouse wheel rolls are too much for what we're looking at. 6.5 kilometers, close enough. We'll go ahead and warp to that maneuver. This is 95.6 meters per second, and an 8-second burn. So let's go ahead and do that for now. Okay. Just warp towards T-minus 8 seconds. Getting very close now. And this is probably because we can't lock to the maneuver node. This is probably going to be off a little bit. Just chase this node ever so slightly as we get our last couple of meters per second. Okay, let's see how that did. 440 kilometers, or 470 kilometers. I can live with that. Okay, so our next maneuver will, of course, be up over here. And we're just going to use this primarily as a marker. There we go. And that's going to be a target retrograde burn because we're going to be intersecting the solar gateway, and then we're going to dock that up. So that is probably going to be the completion of our contract for our solar gateway. Fantastic. For now, we'll head on back to the Space Center and see what else we've got. Although, it is a little bit late in the episode at this point. We'll just see what else we've got needing to happen here. 92 days on the science rover Markduna. Okay, and then after that, it is going to be an additional about 20 days. That's fine. We'll get rid of this debris. There we go. We do not need to track that. However, it is pretty much time to put a cut in here, so I'm going to go ahead and do that. And next episode, we are going to bring in the science rover Markduna. You can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and I will see you all next time.